Welcome back to Wood Engineering. I'm Jeff Rochko from Carleton University, and this video is just a short structural analysis example using the program STRIAN, which is a online structural analysis solver for simple 2D frames. This will help with the project that we have in our course, but it's just going to be basically a simple sample analysis. And so I've drawn a structure that's similar to a structure that we have in our course. We have a 2-bay frame. This is a moment frame. We're assuming moment connections at the corners because we have knee braces, which are not shown. And I've put some sample sizes and stuff on here. And we're gonna make up the loads as we go along, but I'm gonna show how to put all those loads on and how to make all the sizes and stuff like that in the program STRIAN. So we're going to draw out this frame. It's 2 by 2 by 2, 2 meter wide bays, 2 meter high bay, and we're going to put all the loads on. We have trusses at the ends of the frame that are in the out of plane direction. These trusses over here, which are putting a large point load on the columns, and then we have some joists that are in between those that are also putting some point loads on the columns. I'm going to space those out manually. Let's say that those joists, just to make it easy, we're going to say that these joist loads are 1/2 meter apart. This will make our modeling a little bit easier since we're just doing an example. So let's say that those are typically 1/2 meter apart. Okay, so I'm going to go in and show you the software. So here's the software here. If you're looking for this, the URL is online, but it is, I'm going to copy it on down here. This is Structural Analyzer with an S.com. This is a hyphen in the middle here, structural-analyzer.com. And if you go to that website, you are going to see something that looks like this. Okay, so now that we see all this, what are we going to do? I'm going to start drawing actually out the sections, and I can start drawing out sections right away. Let me blow this up a little bit first, though. Okay, I'm going to make everything a little bit bigger. Okay. So I am drawing a 2 by 2 frame. So you can see that there's a grid on the outside. It's laid out in, you can assume that that's meters, for example. I can always zoom out. I can zoom in and zoom out using these plus and minus. Okay, so I can zoom out pretty far. I can zoom in. And there's 2 ways I can draw. I can just draw here to here. So I can make, basically, I'm going between 4 and 2 on the vertical axis. That's 2 meters long. Or if I want, I could click the starting point, and then I can add the coordinates manually. So you see in this box, dx is where is the next part going to be in the x-axis, so that's going to be 0 for us. And in the y, we're going negative 2.0 meters. So I'm just going to put negative 2.0, negative up in this case is negative. The origin 0, 0 is in the top right up here. Okay, so now that I moved it, gone away, so I got a 0, tab, negative 2, and apply. So there I've drawn my second column. Okay, I'm going to draw my third column the easy way. And great, there's all my 3 columns. So I've just drawn them in. I have not given them any section properties yet, so I've just drawn in the columns. Now I'm going to draw in the beams. Okay, now I could just draw here to here, node to node. That's my beam is 2 meters long, but I'm thinking ahead. In this case, I want to apply my joist loads as point loads at the locations of the joists. So instead of drawing the continuous beam from here to here, I'm going to draw each individual span separately so that I have a node to put the joist load on. So let's go back to here. If I hit escape, I'll unselect everything, and I'm going to just select this one by clicking it, and then I can either hit delete to remove, or you'll see I can select it and then hit this trash can to remove the section if I made a mistake. Okay, so I'm going to go 0.5. So you see with this, the way the grid is set up, it's snapping to the grid. and I can only go either 0.4 or 0.6. There's no option in here for snapping to the grid or not, but in order to get around that problem, it's no problem because I can put in exactly the location where I want it to go. So I'm going to just say that I want to go 0.5 to the right, no rise, and I'll hit enter. And I can do that again, 0.5 and hit enter, 0.5, oops, 0.5 and hit enter. And then I want to make sure that this actually snaps right to this. So I'm going to actually click the last one. Okay, here again, I'm going to make another one, 0.5, tab to get to dy, then hit 0. 0.5 again, 0.5 again, enter. And the last one, I'm just going to click on here. Okay, so now I've made my frame. By default, when I put these frame members together, they are connected with a rigid connection. If I did not want a rigid connection, which I do in this case, but if I did not, I could select this one. For example, if I had a pin at the left side of the beam, if I had a pinned connection instead of a moment connection, I can bring up this thing that says hinges on the top. So if I say hinges, then I can basically select directly where I want my hinges. I say run now, and then if I click it, it'll put hinges at both ends. That's because that beam happens to be selected. If I hit escape to unselect and run, then I can put my hinges just exactly where I want. So I want it at that end of that beam, or just that end there, or I want it to be like a pin-ended beam on just either end of this beam, then I can, each time I click, I get a different option for where the hinges are. Okay, so if I had pin-ended beams, I could just go like this by repeatedly clicking each one until I get the hinge in the location I want, left side, right side, or both. Okay, in my case, I do not want any hinges because it's a moment frame, so I'm going to leave these off. Okay. So now that I have my sections, I can do my boundary conditions. So, you know, this is right now just some members in space. How do I make my pins at the base? So we can see in our model, we have pins at the bottom. So these are pin-ended down here. So I want to be able to rotate but not translate in any direction. So I do that by using supports. So if I hit supports, I get this menu. It asks me what kind of support I want. So I can use a pin support, roller support. Roller vertical is a roller just oriented so it slides in the vertical direction. Totally fixed, or remove. So let's say I put a fixed one. I select fixed. Then I say run it. After I say run it, I can pick up the nodes I want fixed restraints at. And to stop, I can just hit that pick up nodes now, or I can hit escape. Also gets me out of that. Escape always gets me back to the beginning. So if I want to unselect things or I want to bring menus away or something, I can hit the escape button on the keyboard. Now, oh, well, I made a mistake. I've made these fixed. I actually want them to be pins. So I could just say pinned and re-click it, and that'll change it. Or I can also hit remove here, and then I say run it. Now that I've said run it, I can select whichever ones I want to remove. So there, I've removed those ones. I'm going to go back to pinned, run it again, put in my pinned bases. So everything is good to go now. I have my portal frame. What about now the dimensions of my frame? How do I get the right stiffness? This is an indeterminate structure, so the relative stiffness of all of these members is going to matter. Okay, so first thing I'm going to do is define my properties. Now for wood, I'm going to have to go to my wood design manual and figure out what my E is, for example. So if I go to my properties here, I haven't defined which E it is in my little example, but I'm just going to pick one. I'm going to say, okay, let's say the E for this is 6,000 MPa. So let's come back to here and determine all these things. So let's say that E for all of my wood members is 6,000 MPa. So there's kind of a reasonable median value. If you have the, you should actually use the actual E for whatever grade of wood that you were using if you were doing wood or if you're doing steel. Obviously, this is going to be 200,000 MPa. Okay, then I'm going to need my A and my I for each member that I want to model, right? So my area and my moment of inertia, or second moment of area. as you like. So let's look at these. We'll call these ones member 1, member type 1, and we'll call these ones member type 2. In your model, you might have 3 different ones, 4 different ones, however many you have, right? Like these columns are probably not all going to be the same if I were to actually go and design them, because the middle column will take different loads, obviously, than the exterior columns. Okay, so for 1, this is going to be 140 times 140 millimeters. Those numbers that I put up there are just some assumed sizes. I'm assuming that these are wood sections. So I am going to calculate that. Find my calculator. Yeah, here it is. Okay. So this is going to be 19,600 millimeters squared. And I is BH cubed over, BH cubed over 12, which in this case is going to be 140 times 140 cubed over 12. Which is equal to 32.0 times 10 to the 6 millimeters to the 4th. Okay, so that's for 1. For 2, obviously I am doing this in whichever is the bending axis direction, like the way that they're going to bend. So the columns are square, so it doesn't matter. The beams, I'm assuming, are sitting in the strong axis direction for strong axis bending. So the I that I calculate is going to be the strong axis I. Okay, so for this one, E is the same, but A is going to be 140 times 292. 4880, and the I is going to be 140. Again, this is the strong axis one, so it's going to be 292 cubed divided by 12. And I get 290 times 10 to the 6 millimeters to the 4th. Okay, so now that I have all these numbers and I go back to my program here, I'm going to select the sections part here. Okay, so sections is going to have my A and my I and my E, but you have to pay attention to the units, right? So this is centimeters squared, centimeters to the 4th, okay? And E is not in MPa, it's in GPa. So I'm going to select ID number 1. I'm going to put ID number 1 here. So I'm going to say that's the, I can put whatever ID I want in here. For the first one, my A was 19,600 millimeters squared. Okay, so that's millimeters squared. If I want to find centimeters squared, I have to divide that by 100. And I get 196. Okay, my I, which is in centimeters to the 4, so I had 32 times 10 to the 6 millimeters to the 4th. I have to divide that by 10 4 times, right? 10 divided by, 10 divided by, 10 divided by, 10 divided by, and I get 3,200 centimeters to the 4th. So I had to divide by basically 10,000, right? And then my E is going to be 6,000 MPa, which is just 6 GPa. Okay, so I'm going to save that entry. So now I have section 1. Okay, and if I had another one here, I could take the drop down and see what it is. So now I'm going to add another one, which is section 2. Okay, and section 2 has a cross-sectional area of 40,880. So I divide that by 100 and I get 408.8 to get centimeters squared. Okay, my I in this case is going to be 290, 29000. Let me just double check that. 290 exponent 6. 290 exponent 6. 3, 4. Yep, that's correct. And then same E. So I'm going to save that entry. So now I have defined all of my sections that I'm going to use. You can see if I take my drop down, I can choose one, or the other. You can't really see here the drop down coming up. So let me just show you on this. Okay, so here I have my drop down coming up. I have 2, or I have 1. Okay, so then I can select whichever one that I want. Okay, so I'm going to select number 1. Okay, and number 1 were the columns. Okay, so I'm going to now apply that section to the columns. So how do I do that? I select the correct one. So I've selected number 1 here. I click apply to selected. Okay, I haven't selected any objects, so I have to go over here and select which elements I want to apply that section to. Again, I'm just double checking it's number 1, and I say apply to selected. Now it says section 1 assigned to 3 objects. Okay, now I'm going to hit escape so that that goes away. Bring up the sections again. Now I'm going to do number 2. Okay, and I'm going to select, I can do a box select, and then I could unselect these ones. Oops. Let me undo that selection. How do I get selection of just the ones in the box? Oh, it's very difficult to do. I'm just going to select them individually. That's going to be the easiest thing. Okay, so I've selected all of those, and I'm going to say now apply to selected. So now section 2 is assigned to 8 objects. So those are those 8 beam elements. Okay, so now I have gone through and properly done all of them. Okay. Okay, I can't show the sections. Okay, so now I have set up my frame here, and I can put on the loads. So how do I put on the loads? I come up here, I select loads. I'm going to apply first some vertical loads. So let's say at the joist, at each joist location, I have, let's say I have 5 kilonewtons or something. 5 kilonewtons. So I say what's the load? This is a single load, so I'm doing point loads. What's the angle of the load? Okay. In this case, my angle is 0, so that means it's going to be straight up and down. And I hit run it. Now I can pick the points where I want to put those loads. Okay. Now I also have these truss loads at the ends, which are different. I mean, obviously I'm going to calculate what these should be. Let's say that the truss load is, it's taking up the top half of the roof basically. So let's say that it's something like 20 kilonewtons. So I'm going to say 20, run, and I'm going to add it here. Now that has changed the value of the load that was there. Okay, so if I want to have both of those loads in that location, if I did have a joist and the truss, then I would have to add those first and then put the load. But actually, I don't have a joist here. I only have the truss. So I'm just going to put the 20 kilonewtons there. Okay, so I can change these anytime. So I just changed that to 20. Let's fix it. I'm going to say 5 here, run it. I'm going to put 5. Oops, I put 50 by mistake. So let's change it to 5. Oh. Okay, 5 here. Okay, good. Okay, so now the other thing that I have is an earthquake load. So I have a lateral earthquake load over here that I want to apply laterally, and that was some percentage of the total vertical load. I think it's something like 70% in our example. So of course, I'm going to go through the process of calculating that. Here we have 20, 40, 50, 60, 70, about 70% of that is going to be something like 50. So let's say I have 50. Now I'm going to change the angle this time because I want to apply it in the horizontal direction. And now I can place it. Now I'm actually going to place it in the center. I could have placed it out here, but since this is an earthquake load, it really acts at the center of mass. So, in the example figure here, I've put it on the side. That's fine for the purposes of what we're doing. Maybe to be a little bit more accurate, I'm going to put it at the center. So now I have it in both places, which is no good. So how do I fix that problem? Oh, I need to say remove. So if I remove loads, I'm going to say run it, and then I can just pick this and remove. Now it's going to remove all the loads from that. So I'm going to have to put back my 20 with an angle of 0. back on there. Okay, so now I have all of my loads for my structure, the vertical loads from my joists, the vertical loads from the trusses that are on either end, and I have the horizontal load from the earthquake. I have defined all my sections, and I have defined my boundary conditions. So now I can actually run. How do I run the analysis? I just hit this button here that says solve. And you see right away, it gives me what are my reaction loads. So those are the reaction loads at the pin, at all the pins. Yeah, why do we have such a large load here and such a small load here? Because this 50 kilonewton is providing an overall overturning moment. So it's creating a compression in this column and a tension in this column. So that's why we have a tension. Like it's basically we have the vertical load here, then which is a compression, and then minus the tension from the overturning moment. Okay, so these make sense. Now, if I want to see all the diagrams of this, maybe I can zoom in a little bit more, actually. That might help. Okay, so now let's look at the diagrams. So if I say diagrams here at the top, then I can select what I want to see. Okay, so let's look at, I just want to see the moments. So now it's showing me the moment diagram. I'm going to turn this off. Okay, so now it's showing me the moment diagram. So I can actually see what are the values at all these points. Okay, so I have 32.07 at the end here. Okay, so that's my moment. You can see that the moment is not totally even between these two because we're doing a indeterminate structural analysis. I can see the moment in the column at the top here, 32.6. I can also pick up some in between ones. I mean, obviously this should be a straight line for this particular analysis, for the columns, certainly. Yeah, and if I don't like, right now this is drawn basically on the, which side? Right now they're being drawn on the tension side. If I prefer my moments to be drawn on the compression side, then I can just go to reverse here and turn that on, and it'll draw it the other way. So it just depends on what's your preference for drawing moment diagrams. Doesn't matter. Okay, so let's turn that off. I can look at the shear diagrams. Okay, so this is the shear in my beam in each location along the beam. I can look at the, this is the axial force diagram, which will be important if you're designing beam columns. Okay, so obviously for design of the corner columns, I'm going to want to use this axial force because this is the worst case. And if I want to see the displacement, I can go to D here. This shows me the displaced shape. And if I want to see what the actual displacement is, I just have to hover over one of these points, and it's going to give it to me in base units, right? So if this was, I did everything in meters, right? So I had 1 meter, 2 meter, 1 meter, 2 meter. So this is in meters. So my horizontal displacement here, 2.44 times 10 to the negative 1, that's 0.244 meters, which means it's 244 millimeters. Okay, so that's about 10% of the total height, a bit more than 10%. So that would not fit an NBCC deflection limit. Okay, so I would have to beef up my columns if these were my loads, if I wanted to meet the deflection limit, which was an optional part of our assignment. And that's basically it. So I'm able to get my moments and my shears and show my deflections. And you'll notice that the beam, since the beam is much stiffer than the columns, we don't get much bending in the beam. There is some bending, certainly, but it's just relative to the columns, it's not very much. So probably what I want to do is beef up my columns. Why don't I just go ahead and do that? So if I go to section 1, which was the section of my columns, let's assume that I designed them to be bigger. Maybe I made them the same size as my beam, which had an I of 2900 and an A of 408.8. So I saved the entry. So now 1 and 2 are basically the same. I can see which section I'm talking about if I hover over. You see it shows me that section 1. This one's section 2, this one's section 1, this one's section 2. Let's resolve it. And now what is my deflection is now only 37 millimeters. 3.69 times 10 to the negative 2 meters. So now I have a much smaller deflection, and I'm going to check my moments against my moment capacities, obviously, and my shears against my shear capacities, and my beam column resistance against my moment and axial together. So that's basically it. That's how you would use this program to come up with moments and shears and calculate deflections as necessary. Pretty easy going. Doesn't take too long. And the whole thing, including explanations and everything, only took about 25 minutes. So hopefully that would be the same for you. So good luck. Have a great week.